Hey there! So, in this video, we'll be talking about trends in graphs. And the important question is, what is a graph and why is it important to us? Well, a graph gives us a lot of information based on a picture. Because let's face it, nobody likes to look at a list of numbers. So, people would rather get a lot of information by just looking at a picture. A quick glance at a graph can tell you a lot. So let's get started. So let's talk about some definitions. What is a graph? It is a visual representation between two quantities. So it's basically, in a sense, it's a visual representation between. It could be two. It could be more quantities, but in most cases, especially for you guys, it'll be between two quantities, two-dimensional. Um, it shows how one quantity changes with respect to the other quantity. So like x over y, so y over x, distance over time, things of that manner. So trends is basically a pattern. What are you seeing? Is the graph increasing or is the graph decreasing? Is the graph staying the same? So the best way to describe it is to go through some examples. So let's go through an example here. Okay, so example one. Here, Jack's babysitting earnings. So first of all, I can tell right away by just looking at this graph, it's a line. It's a straight linear line. So that's what you want to take away. This is a linear graph. So it could be either linear or non-linear. And if it's non-linear, it could be exponential or it could be a quadratic. Quadratics typically are like a U curve, sorry, U curves, and exponential is just something that curves upwards or curves downwards. Maybe I should show you an example here. Let me just see if I can find my pencil tool. Here's pencil. Okay, so basically, exponential looks like that. X. Typically, that's how it looks like. Not always, but most times. Whereas quadratics either looks like that or like that. Oh, exponential can also look like that, like a curve down. But you can't really tell if it's exponential or not exponential. These over here are quadratics. So they're quadratics. And yeah, but that's beyond the scope of this. We'll be talking about in another lesson. So I just want you to identify that. Also, you should know that well, let's take a look at some of this here. So let's get my highlighter tool. Okay, so let's look at this graph here. This is the earnings in hours. I can tell right away it's a linear graph and it's increasing. So the number of hours is increasing. The number, yeah. So earnings is increasing. Not as the numbers of hours work increases, yeah. The earnings increase. The earnings are increasing by a constant amount because you take a look here, if you look at 2 points on the graph, let's say you look at that point and you look at this point, they're both increasing by the same amount. So you can say that not only is the earnings increasing, but but the rate of change is constant. Now that's a bit different than earnings being constant. If the earnings were constant, let me just get my pencil. If the earnings were constant, it would look like that. So basically, you're making no money over time. You're making no money over time. Oh, let's just put time. Oops. Okay. So here, so that's what you can tell from this graph. The earnings are increases with hours worked. So the more hours you work, the more money you're making. Okay, so that's for that graph. Let's take a look at this graph. Now this one is a non-linear graph because it's not a line, but we do not know if it's a quadratic or exponential graph. The quadratic, well, that'll be taught in a later lesson, but all you need to know right now that it could be either quadratic or exponential, but they're both not, as non-linear. Okay, let's highlight that. So the amount increases over time. So this is the money, the amount invested is increasing over time. So it's going upwards. It's increasing over time. Okay. Increases, but here it increases slowly, so you're earning a little bit of money. So it's going upwards, very small increase here, but later on the increase jumps quite a bit with the amount of time. So this is the time going across is the time, and going upwards is the amount. So with very little time, it increases dramatically. Here, with this amount of time, it increases just a little bit. So it here it increases slowly at first, then more rapidly later. So increases a lot more there. And the rate of change is increasing. So the rate of change is basically how much is like this. Basically, if you had to draw a line from here to here, it's the rate of change is not much, but over here to here, the rate of change is quite a lot. So the rate of change is not the same. The rate of change here is different than the rate of change over here. In short, let me show that. Let me pull up my pen tool. So the rate of change over here is like that, going like that, and the rate of change up here is like going like let me just erase that. It's going like that, like the slope is steeper. It's a steeper slope. The slope here is not as steep. It's it's like that. The slope is not as this, but this slope is much more steeper. So the rate of change is not the same. It's increasing. Okay, it's the next problem. Okay, so the temperature of the coffee cup. Now this is a bit of a tricky question. This one, again, this here, the temperature decreases over time. So here that you can see is going over time, it's decreasing. And you can see here that it decreases quickly at first. Over here, the rate of change. The vertical is the rate. Basically, it tells you the rate. So over this much time, it decreases quite a bit. So it's very steep. And over time, over this amount of time here, is assuming this time are about the same, the decrease is less. So it decreases quickly at first, then more slowly. Oops. Let me just undo that. Then more slowly afterwards. The vertical distance between pairs are decreasing. So let me just get my pencil tool. So over here, if I had to draw a line from here to here, that is the slope. And over here to here, the slope is more flattened here. So over there it looks like that, and over here it looks more like that. So it's more flattened. So you can tell that the rate of change is changing. The rate of change is decreasing. So it's going from here to here. Let's see, this is a nonlinear graph. We talked about that. The temperature is becoming constant near the end. What that means is near the end of this graph, it's most likely going to curve down like that, like forever like that. So it's becoming more constant. Let me get my red. Let's see if I can find red here. Here is red. Oops. There we go. So it looks like that. So it's becoming it's becoming more of a straight line. So it's more of a straight line. Okay, so now let's read this graph here. Fertilizing the fields. Now, I can tell right away the rate of change is decreasing, but at first, it the rate of change is increasing a little bit at first. So the crop increases a little bit in the beginning. So it goes up a little bit in the beginning, but then the crop sort of decreases the further time as more fertilizer is used. So that's true in real life. If you have a garden, if you try to use fertilizer, you get some great change with a certain amount of fertilizer, but too much fertilizer is bad. Too much of anything is bad. So it the crop increases initially, but then decreases over time. The vertical distance between pairs of points, meaning that if you had 2 points from here to here, like basically from here to there, it's pairs of points are decreasing and then increasing. So it becomes here it becomes more steep. Let me change the color there. And again, this is a non-linear graph because it's not a line, but you do not know if it's quadratic or exponential. So we'll be talking about that later. The temperature becomes constant near the end. Oh wait, this is wrong. Okay, I'm gonna have to change that, but this is wrong here. All you have to know that for this graph is the crop yield decreases over as more fertilizer used, and that's about it. Everything else here is, I guess, you don't really need. Just so you can scratch everything else out here. You don't need that. Okay, let's move on. I'm gonna fix the notes on this. Okay, here, this is a good one. It's talking about basically when you read the graph, you have to describe the graph, what's going on at each point or a group of points. So this first one here, let me see if I can find the red marker. So or let me use yeah, let's use the black, or we can use red. So from here to here, hmm, that doesn't look good. Okay, let's try blue. Green, blue, with a weight of 2. Okay, so let me from here to here, that there is basically, it says right here that the birth rates are increasing, so you see an increase in birth, but from here to about here, it is actually decreasing, so the birth rate is going downwards. But from here to here, from these 2 points, it's constant. So that's right, this short interval between this point and this point, it's not increasing or decreasing. It's a straight line going on the vertical. It's straight on the vertical, which means that it's constant. And again, from here to here, from those dates, it is increasing again. And then finally, from the last stint, the last time frame, it is decrease. Oh, not from here to there. Let me just erase that. From Well, from this point on, from here to here, from this point here, you can tell right away that the birth rates are decreasing, and then again it starts to increase from here to here, from there to there, it increases. So on a test or the exam, you'll be given a graph like this, and you're gonna have to tell me from what point to what point it's increasing, and from what point to what point it is decreasing, what point to what point it's constant, and so on and so forth. So you got to sort of describe what's going on in the graph. Okay, let's do the next one. Now this one's a little bit tricky, because it's asking you here in the bottom part by 2010, right? So you're gonna have to make sort of an estimation, because this is 2000, 2010 is probably around here. And assuming that you extend the graph and you can make your best guess at what those numbers are. Here would be up to here. That's blue. Let me grab red. So you're just making a sort of an estimation. And this one should be green. Okay, this is good enough. And use black. Okay, so it says here, use the graph to predict the number of Canadians uh, in each group. So basically, what's the population at 2010? Well, we're looking at under the age of 15, right here, under the age of 15, on the red. You follow the red, and if you like sort of extend the graph to 2010, so 2010 is about 10. So you're making a sort of educated guess. And if it follows the way it's going, then you should make a guess that the population would be, if you look here, it's right over here. About in the textbook it says 5.8 million. These are millions. This is 5.8 million, so it's right over here. That's not working. Um, and over here it says here, and underneath, at the age of 60 and over, if the trend continues, it'll be about, I think, about maybe more. In this case, it says 5.7, so it's assuming that it's stopping. It's just below that. So this graph is a bit the way I extended it, but I didn't extend it all the way. So if the trend continues, let's say the trend continues like, let's pull that away. Let's say the trend continues like that, and then over here is 5.7 million at 2010. And over here, at the age of 80, as you can see, it doesn't really increase much. You look at the green, and if you extend it all the way to 2010, it's about 1.0 million. And in the future, if you have a business, you're most likely going to be making graphs, and then you might have to like extend the graph using a ruler or whatever tool you want, and then you're gonna have to make some predictions. And it'll give you an idea as to whether or not how to run your business. Okay, so these are things you got to think about. So, what decision might the Canadian government make in response to the trends in graph? So, it's saying that if you look at the trending graph, the trend suggests, and let me just get my highlighter tool. The trend suggests that a declining number of Canadians, younger Canadians, will have to support an increasingly larger number of elderly Canadians. Why is that? Well, let's take a look. Look how many. If this trend continues, the people over 60 is increasing quite a bit. Right, so there's gonna be a lot of old people in the future, whereas young people it doesn't look like it's actually they're increasing or decreasing. It looks like they're staying the same number. And the people over 80 is age over 80 and over. Well, it's not that many, but it's increasing. So it's saying that it's saying that the government, like if there's not enough people if to take care of the elderly, you might have to increase immigration levels. If there's too many, like in Japan, that's what's going on in Japan. There's not enough young people. Everybody is really old there. Nobody wants to have kids, unfortunately. So you may have increased immigration levels. So we need more people because without immigrants, then or without people, nothing can run. Right? You know, people. Someone has to make the houses. Someone may has to build the roads. So you may have to increase immigration level and pull people in from other countries, so our country would work. You may have to increase the retirement age because if there's a lot of old people, then it's going to consume a lot of money, and they're not going to have enough to live. So that's what they're doing in a lot of places. You're retiring a lot later, which is I think is a crime, but that's the reality of things. Things are expensive, especially with inflation. And you may have to strengthen healthcare and social security because when you're old, you use your healthcare more when you're old than when you're young. When you're young, you're pretty healthy. You don't want it. You don't have to use healthcare or your social security. But when you're older, people are retiring and they need a retirement plan and they just need to be taken care of. People need to be taken care of when they're old. So if we're having an increasing amount of elderly people, then we have to take care of them, and we have to pull in more people into the country so the country would work. Okay, so that's about it. That's the end of the lesson. Yeah, that's about it.